I'm not sure if I remember to put the answer key on Moodle or not. If I have not, I will do so after class. I think I forgot to post it on Moodle now that I'm thinking about it. Once you have a chance to review what you've missed, feel free to come in and see me or see Hope. I think Hope has office hours today, right? 2:30 to 4:30? Is that right? Yep. So see Hope or go to the Math Center, have them review over things as well. We're all happy to help you get back on the right track. But if you were unhappy with how you did on the exam, like I said, go through the key when I get it posted on Moodle. Go over what you missed. Happy to work through things with you as well. Like I said, we'll make sure you're on the right track with those things. In particular, things like domain will pop up again later in the semester. Being able to understand graphs, because we'll build up onto different types of functions as we go along. Making sure we understand graphs and graph transformations, that stuff will pop back up as well. So make sure you get things corrected so we can get things. There's plenty of time to get things made up. If you didn't do as well as you hoped, still got 3 more exams, still have the final. So in any event, like I said, review, make sure that you understand what's going on, and if you need to come in and go over additional things, come see me, come see Hope. We're happy to help. All right. Well, let's get started into some new stuff today. So we've been talking about functions. We'll talk about functions all semester. But what we're going to talk about now is putting two different types of functions together. You kind of do that anyway when you do polynomials, because we've already talked about power functions, x to positive integer power. So you can think of your polynomials as just sums and differences of power functions, if you like. So you've already talked a little bit about combining functions, but we'll build a little bit more formally today and talk about things like domain and domain of these things. And then we'll get into a type of combining of functions that you probably haven't talked about before. All right, so let's just talk about arithmetic operations on functions. And what I mean by that is just adding, subtracting, multiplying, dividing. Notice our notation here is that I've got 2 functions, f and g, to start with. This is just saying that I want to add those 2 functions together and then figure out what the output is depending on the x. So that's just the notation. This is that I'm going to subtract the 2 functions. This will multiply. This will divide. But you can probably guess how we're going to do these things. If I want the output associated with the sum of the 2 functions, I'm probably going to take the outputs of the 2 functions and add them together. Yeah. So again, this is the notation, f plus g of x. This is just telling you what you do to calculate it, which is exactly what you would expect it to be. Right? Take the output for f, take the output for g, and add them together. So what would you think you get for the next one? F of x minus g. Yeah, f of x minus g of x. Good. And the next one? Yeah, f of x times g of x. And the last one? F of x over g of x. Good. Exactly right. Yep. So these are the 4 arithmetic operations that we'll do with functions. Add them, subtract them, multiply them, divide. And again, shouldn't be a huge surprise as to what you would do, right? Take the outputs, add them, take the outputs, subtract them, and so on down the line. So let's look at this first example. Notice they don't give you an explicit function listed, but they do tell you the outputs associated with f and g for the input 2. So in the first case, we want to find f plus g of 2. By the definition that we just said we had, you can rewrite f plus g of 2 as what?
F of 2 plus g of 2.
Good. Yep. F of 2 plus g of 2. Good. All right. Are we given the output associated with 2?
Yes.
Yeah, f of 2 is negative 12. G of 2 is 11. Add those together and get negative 1. Okay. So what's going to be different about part B? Just subtract them instead. Good. Exactly right. We'll have f of 2 minus g of 2. And again, f of 2 is negative 12. G of 2 is 11. I'll go over to plus sign again instead of a minus. So then we'll get negative 23 in that case. Yeah. For the next one, what will we do?
Negative 12 times 11.
Good. Yep. We'll multiply the outputs together. You get negative 132. And then finally, in the last one, we'll divide them. Oops. And we'll get negative 12 over 11. That okay? And again, you can reverse the orders of these things if you wanted to. For example, I mean, obviously, if you did G plus F, you'd get the same answer, or G times F, you get the same answer. But if I did G minus F, I'd flip the order of the subtraction. Right? If you did G over F, you'd flip the order of the division. Flip it upside down. Is okay? Work on the next one for a second, and then we'll chat about it, and then we'll go on and talk about domains. Yes? I would leave them as improper fractions like that is. I wouldn't change it. I wouldn't change it to mixed numbers. Yeah. What did we get for the first part? Negative 1. What did you get for the second part? 3. Third part?
Negative 2.
Negative 2. Oops. Maybe. If I did right. And for the last one?
Negative 1/2.
Negative 1/2. Okay. Are those okay? We all right with those? Not too bad, right? Adding those outputs. All right. So let's talk about domains of sums and differences. Sums, differences, products, and quotients. So notice how we've defined these things, right? No matter what, if I plug something in for x, it has to go into both f of x and g of x, right? So if I'm going to look at the domain of these, we need to make sure that this is going to be the set of all x's that are in the domain of both of them. Okay, so you look at the domain of f, you look at the domain of g, and make sure that it's in both at the same time. Okay. In math, we talk about something that's in both sets of things at the same time as the intersection of the two sets. You may see hear that word, but it has to be both in both at the same time, right? Because again, if I'm going to plug something into one of those operations, it has to go into both functions. So it has to be in both domains. Okay. The same thing is true for the quotient. It's still going to be the set of all x values. Guess I forgot the word "the" in there. But there's going to be an extra little piece also. What's the extra little piece that we have to worry about when we do a division? Yeah, so we want to make sure that when we plug in the x, we don't make the denominator 0. So it has to be in the domains of both f and g, and does not make g of x equal to 0. Okay? So you got to plug it into f, you got to plug it into g, but you also have to make sure with the quotient that it doesn't make that denominator equal to 0. Because then you'd be dividing by 0, which causes problems. Breaks the space-time continuum. Causes dogs and cats to live together. Anyway. So you got to be careful when dividing by 0. So let's look at some examples. I think the examples make the case of what's going on. So for the first part, it says that we've got f plus g of x. It's asking us what's the domain. Well, let's first find, well, actually, it asks us to find it, and then asks us the domain. Again, by the definition, pardon me, this f plus g of x is f of x plus g of x. What's f of x in this case? Negative 5x. What's g of x? X squared minus 1. That is the sum of f and g, but ordinarily we like to write our powers of x in decreasing order. So if I flip it around, we'll have x squared minus 5x minus 1, and that's it. That's all we would have for the sum of f and g. What kind of function is this? It's a polynomial, right? We've got x to positive integer powers, right? And a constant on the end. It's a polynomial. We actually refer to this type of polynomial as a quadratic polynomial because of the x squared term. I'm sure you've heard of quadratic formula, right? It talks about how to solve these things equal to 0. This is a quadratic function, and we'll spend some time on properties of quadratic functions in a few days. Okay. All right. What do we know about polynomials? Do we have any denominators in polynomials? Are there any x's in the denominators for polynomials? We said we had to have x to positive integer powers. Are there any x's in the denominators? No. Any x's under radicals? No. So what's the domain of that function? Yeah, negative infinity to infinity, right? There's no domain problems, right? Those are the two big domain problems that we have so far, right? Negatives under square roots, zeros in denominators, right? Those are the two big domain issues that can pop up. Does this have either of those two big issues? No. So the domain must be all real numbers. So the domain in this case will be negative infinity to infinity. And notice the individual pieces here. What was the domain of the first function? Negative infinity to infinity. Also for the same as the second. So the sum will have negative infinity to infinity as the domain as well. All right, so we have no domain issues plugging into f or g. So we had no domain issues for the sum. But what's going to be different about the quotient? What do we get for f over g of x? Good. F of x is negative 5x. G of x is x squared minus 1. So we get negative 5x over x squared minus 1 is the quotient. Now again, here's how it says that we're supposed to look at domain for the operations. Look at your domain for f of x. Any problems there? No. Look at your domain for g of x. Any problems there?
Yes.
Well, just literally that part. Is there any problems for that part? No. But overall, are there going to be problems? Yeah. Yes. What can't we do?
-1.
Divide by 0. Good. Yep. So we can't divide by 0. So we need to set that denominator equal to 0. Let's factor it because this is a difference of two squares. How does x squared minus 1 factor? Yeah, x plus 1 and x minus 1. I just want to remind how we solve these types of equations, right? We factor. We set each piece equal to 0. Yeah. Those are the numbers that x can't be, right? Those are the things that we cannot plug into the denominator. So what's your domain going to be? We're going to go negative infinity up to -1. Well, there's going to be a 1 to infinity. I agree with that. Yeah. -1 to 1. Why would they be parentheses and not brackets? They are parentheses. Why are they parentheses and not brackets? Because these are the numbers that we don't want, right? So do we want to include them? No, remember, bracket means they're included, right? So I don't want to include those. So I'll use parentheses all the way through. One okay? Work on that next one for a minute, and then we'll chat about it. When you do f minus g of 3, what do you do?
Take the root of 3x minus 5 and you input 3, so the root of 3 times 3 minus 5.
Okay. Yeah, so remember the definition is just to do f of 3 minus g of 3, right? So the first case, we put in 3 into the first function, right? So that's square root of 3 times 3 minus 5. And the second one, 4 over 3 plus 1, right? Just plug it into both. Yeah. 3 times 3 is 9, minus 5 is 4. Square root of 4 is 2. 3 plus 1 is 4. 4 over 4 is 1, so we end up with 1, right? Alternatively, you could have done f minus g of x first. Wrote it as f of x minus g of x, which would just have it with x's in it, right? Minus. Not a lot of simplifying you can do, but then you can just plug in your 3 again, right? You could have written it out with x's first and then plugged in 3 in as well. Either way works. Okay? Doesn't matter. Okay. What about f times g? Okay. So 3x minus 5, root 3x minus 5 times 4 over x plus 1, right? Then when we multiply straight across, right? Multiply tops and multiply bottoms. Yep, I agree. Okay. So we have 4 times root 3x minus 5 all over x plus 1. Multiplying those two pieces together. That part okay? All right. Second part asks for domain. So far this semester, again, we talked about two big issues with domain, right? What are they?
Think about it.
The negative under the radical and divide by 0, right? This has got a little bit of both, doesn't it? Right? Okay. So what makes it? What would you not want to plug in for x in the denominator? Well, for x in particular, you don't want a 0 in the denominator. What makes the denominator equal to 0? -1 makes the denominator 0, right? The x plus 1 being 0. Good. So we need x not equal to -1. What else do we need? What's the other thing you see that could be wrong?
Radical with the negative.
Yeah, radical of the negative. So we need 3x minus 5 to be greater than or equal to 0. That was like a problem you guys had on the test, doesn't it? Okay. Solve for x. So that says that x needs to be greater than or equal to 5/3, right? Now, pardon me. Is -1 greater than or equal to 5/3? No, it's less, right? So I don't need to worry about the negative. I don't need to worry about the -1 in this case because it doesn't satisfy this one, right? Okay. So what's your domain going to be in this case?
Negative infinity. Oh.
No.
It's the other way, right? So it'll be 5/3 to infinity, and what'll go on the 5/3? A bracket or a parenthesis?
Bracket.
A bracket in this case because it's on the top, right? Okay. Questions on that? Okay. All right, we'll work on the next one for a minute, or I'll give you 2 minutes. That's fine. Work on the next one for a little bit, and then we'll chat about it. Or at least the first parts of the 2 parts were not bad, right? Creating the quotients, right? The first one says do f of x over g of x. The second one says do g of x over f of x. So the first one, what are you going to get?
Root 6 minus x over x squared minus x minus 2.
Good. And the other one?
X squared minus x minus 2 over root 6 minus x.
Good. Yeah, just flipped upside down, right? Those parts were okay, I assume? Okay. Yeah. It literally is just take one over the other, right? Not too much of a big deal there. All right. So in both of them now, notice that we have a square root and a denominator, right? So we have to pay attention to both. Okay. Let's take care of the square root first. What do you need the 6 minus x to be? Greater than or equal to 0. It's on top, so I can still have it equal to 0, right? So if you solve that inequality, what do you end up with?
X must be less than or equal to 6.
Yeah, the x has to be less than or equal to 6 in that case, right? Yep. That part okay? All right. What other piece do you need to make sure doesn't happen?
Divide by 0.
Divide by 0, right? So set that denominator equal to 0. And again, when we solve these, we want to try, if we can, we want to try to factor it, right? How does that factor? Good, x plus 1 and x minus 2, good. So again, if we set each piece equal to 0 and solve, we'll get x is -1 or 2. Okay. And again, these are the x values that we can't use, right? Right. So one thing that might help, at least in my mind, one thing that might help with getting the domain is to draw the picture with the number line, and then we can read the intervals off, maybe. Okay. So if I have the number line, I've got an issue at -1. I've got an issue at 2. And I know we're going to stop at 6, right? We don't want to include the -1. We don't want to include the 2. We do include the 6, but which way would I shade from 6 for that inequality? Left or right? Left. So I would shade this way. I don't hit that. I leave that open, right? I hate when it does that. If it thinks I'm scribbling it out, so it doesn't want to color it. Right? So I'd shade there. I would shade here, right? I would shade this way. Okay. So now can we write, there's 3 distinct intervals we see there, aren't there? Can we write them for the domain? What are they?
Negative infinity.
Good.
Negative 1 to 2.
Okay.
And 2 to 6 with a bracket.
Good. And then the 6 will be included in that case, right? Notice that the 6 is a filled in dot, so I want to use a bracket there. But I want to eliminate the negative 1, and I want to eliminate the 2, because I can't put those in the denominator. If you don't like the picture, you don't have to draw the picture, but sometimes I think the picture helps to be able to see the 3 distinct intervals that we have, right? I need to make sure I eliminate negative 1. I need to make sure I eliminate 2. I don't want to go any higher than 6. And then so I shade in between for the rest of them. That make sense? Is that okay? What's the difference in the second part?
You have to account for the 0 and the negative.
Good. So notice that in the root 6 minus x is now in the denominator. So instead of having 6 minus x is greater than or equal to 0, we need 6 minus x is strictly greater than 0. Yeah, exactly right. I can't equal 0 anymore for that one, right? Because it's in the denominator. This looks like exactly what was on the test, doesn't it? Okay. So x will be strictly less than 6. Are there any other problems?
I thought, was it the negative? Does that not make it negative 6?
It'd be the same set of solving that you would do
Oh,
here.
okay, no,
Yeah.
because when you subtract
Yeah.
6, yeah,
Yeah.
I get it. Thank you.
You're welcome. Are there any other problems? What I'm asking you is this causing any problems up here? No, that's a polynomial and it's on top. I'm not dividing that anymore, am I? No, so this literally is the only thing we have to worry about. So what is the domain?
Negative infinity.
Good, negative infinity up to 6, and we don't include the 6 this time. So we don't have to worry about deleting out the negative 1, the 2 here because we flipped it upside down. All right, so again, moral of the story, worry about the domain of the top, worry about the domain of the bottom, but also worry about when the bottom is 0. All right. The next type of operation we're going to talk about is not an arithmetic one. It's a composition of two functions. So, to give a physical example of what you might be doing, when you leave the house in the morning, one function you might do is put on your socks. And another function that you might want to do is put on your shoes, right? Now, you could put on your socks and not put on your shoes. You put on your shoes and not put on your socks. And theoretically, you could put your socks over your shoes, right? But the idea of composition is do one function and then do another function right after, right? So think of it as your input, bare feet. You put your socks on, that's the output, right? Now you've got a new input, socked feet. You take your socked feet, those outputs, and put it into the shoes, okay? That's what we mean by composition, right? You're going to do one function, take that output, put it into the next function, okay? So by definition, we use the circle here. It's not an O, it's a circle, okay? So don't say fog. Doesn't make any sense, okay? This is F composed with G. The idea here is, again, you're going to put the input into the first function, and then that's going to be the output is going to be the input into the other function. Okay? So it's f of g of x is exactly how we say it. F of g of x. So input goes into the g first. You take that output, and then you put it into f. Okay? So when we do the composition, if we're worried about the domain, this is the set of x's. Well, where's the first value where's the first place the x value has to go into? If you're going to do the composition, where does the first place it go? Into G, right? It goes into G, the first one, right? So it's the x values that are in the domain of G, and then the G of X goes into the F. So it's the set of X values that are in the domain, of G, I'm in there. And G of X, the output, is in the domain of F. Okay. It's a lot of words. It's a lot easier to do it with symbols, which we'll talk about later on here. Okay. All right, so let's do the first one. This one says find F composed with G of 1 if we have F of 2 is negative 10 and G of 1 is 2. So again, by definition here, F composed with G of 1 literally means F of G of 1. And in these compositions, we're going to work inside out. This 1, the first place it goes in is to G, right? So let's simplify that part first. What is G of 1 equal to according to the problem? 2. So we'll replace the G of 1 with the 2. Do we know what F of 2 equals?
Negative 10.
Yeah, negative 10. So we're done. Okay. So let's do the next one here. This one says do F of G of 1 again. Oops. So that's F composed with G of 1. So that's F of G of 1. Which function does 1 go into first? The G of X, right? Okay. So I'll write it out. That's 1 to the 2/3 power plus 4, right? And let's simplify that. The reason why I put this with an fractional exponent is I wanted to remind you what it means. If you have a number in the denominator here, that tells you what? It's the
root.
It's a root, right? So this is a cube root and then square it, right? This tells you what the numerator of the fraction and the exponent tells you what power to take. The denominator tells you will take what root to take. So this says take the cube root of 1 and then square it. Cube root of 1 is 1, squared is 1, plus 4 is 5. Yeah. So this is F of 5. Now where does the 5 go?
Into the 2x plus 4.
Good. It goes into the 2x plus 4. Fantastic. And so we'll simplify to 14 in that case. That okay? Okay. All right. So do the next one. Do that next, just the very next example. Then we'll chat about it, and then we'll do some more of these on Friday. Here, right? This is G composed with F. So that's the same thing as what? G of F of 7, right? So which function does the 7 go into first in this case? The F, right? Absolute value of 7 minus 5 is 2. So we get G of a half, right? All right. Now where does the 1/2 go? Into G. So we get square root of a half plus 2. The square root of 5 halves. It is what? I'm sorry?
I put it as an improper for that, I think.
That is an improper fraction because when the numerator is bigger than the denominator. You mean mixed number? Yeah, don't put it as mixed numbers. Leave them as improper fractions. If you really want to, we could split up the radical over top and bottom, and then we could rationalize the denominator. You get that? As long as you get to this part right here, it's okay. Are we okay with that part? Notice I flipped it around, right, Anya? I did G composed with F. What if you did F composed with G instead? That's 1/2. Yeah, isn't it? Yeah. So that's F of G of X. Or F of G of 7. So you'd have square root of 7 plus 2 on the inside, right? 7 plus 2 is 9. Square root of 9 is 3. So you get 1/2 in that case. So you did it right if you flipped it around. Yep. All right. Is that okay? Yes, Maya. All right. We'll do more of these on Friday as well as get into the next section. So have a good one. We'll see you then.